All right, the last topic in coding, object orientation. This is a little. This is every almost all the codes. If it is written in professional way, then that is object orientations. The concepts that we learned and the languages, all the statements that we learned so far, are still valid. That is the main implementation in object orientation, object-oriented programming. We simply switch our concept a little bit toward object orientations. That is what we have, what we are currently in this real world. Okay, so coding structures three ways. Flat coding, a single sequence of logics. That kind of coding has been that's started in that flat codings. When I learned my coding when I was young, first few, I think 1 year, it was a flat coding. And after that, immediately modular coding in modulars. So when we code, then we want to make it small modules. And there are a lot of interactions among those modules. For example, the function definition. That is one nice module, right? We can have multiple different the functions, and we can and another the main code that is flat codings. There we can invoke one function after another and after another. We can mix. We can invoke multiple different functions that we may implement, or we may simply borrow from anywhere. And after that, object orientation. So what is object? Any similar objects can be grouped together and designed in a basic common blueprint. For example, camera lens. Then there are so many different kinds of camera lenses available, right? In our coding, if we want to code, then we don't really stick to one lens after another and another. Then our code may not ready to adopt some lens that we didn't originally consider, or some lens has not yet come out. All such things possible. Then our code needs to be updated, modified, or terminated, newly re-implemented. All such things possible. So why don't we have a blueprint for many objects which are not totally independent, which are not totally different, if they are common somehow? For example, if we design about human beings, then we can group the students all together. Therefore, we can see some common features, and those features can constitute the blueprint about the students. So, for example, GPA, major, or advisor, those things are available for all the students, which it may not be available for example, some seniors, right? It's apparently different, right? Those are completely different from furniture. What furniture can be structured is not really similar to the structure of students. Okay, so when we describe some objects, therefore, if we want to define the class, that class is nothing but a blueprint. If we want to design the blueprint for similar objects, same kind of objects, then there are two things that we need to consider. Some features, some descriptions about that objects, there are static, right? Static aspects of the objects. For example, name, date of birth. Those are all static aspects describing about objects. On the other hand, there are also various different the features, which is behavioral. For the students, calculating GPA, that is behavioral, there's a dynamic, it's not static, right? GPA should be updated while you are in the student class. So those behavioral aspects of objects can be implemented in functions. So we can say DEF and function name. So various different functions and also static aspects all together we encapsulate. So encapsulation is an important concept here. Encapsulate. So group put them in one capsule. So encapsulations. And that is called, the blueprint about that encapsulation is called the class. So object-oriented programming starts with defining definition of classes, class definitions, rather than thinking of objects. Well, yeah, we first start thinking about object, but real coding start from defining classes. So we first define blueprint, and then we can create multiple different objects that we want. Okay, this diagram, this picture, actually from this the real world objects. So instead of repeating same definitions for each lens, we can make some definitions like a class. These are all, there are so many different objects of lens, camera lens. They are same class, same type. Therefore, we define that as a class first. And then we can say a lens, if it is a lens, then lens has a focus length and aperture. Those two typical features. Those are all static aspects. So we need to define first. Once we define this, then we can describe each different objects. Hey, this object, this lens, focus, there's the range of focus from 1 to 105. And aperture, that is also range 4 to 8. And the other lens, the fixed focus length, so 55. And aperture is very, very, very expensive ones, 1.4 to 8. Various the apertures. Another maybe the zoom lens and different range of the apertures. More in coding way, then we can say we define class. The way that we can define class is start with the class, name class, all lowercase, CLASS, followed by class name, lens, colon. So after this, there are all the features about the lens. They are encapsulated under this colon. So within this code block, entire code block is the encapsulation of lens. And as you can see here, this is a definitions, like a function. But if you see the function name here, this is, you may see this kind of function somewhere, right? In the definition of the class, definitions of, library of those. Then you see this multiple times. I may show to you, for example, here, if you see Python help, and then help, and then for example string, then see this kind of things, right? Underscore, name of function, ending with the double underscore, and then this, and then the signature, the parameter of that the functions. Some of there, definitely we see This guy doesn't have init, but some other, for example, list. Then if you see the list, then we see here init, right? Underscore underscore init underscore underscore, followed by the list of the arguments, self and slash possible, and star argues. Now you may know why we have a star. If we have a star, then an arbitrary number of arguments, right? And then there's a double star. Then this is the form of the dictionaries. But anyway, the list of the parameters for this function init. But this function is not typical functions started with the alphabets, but underscore and underscore. If we have a double underscore, then that is special functions. We call that magic functions. Why it is magic? Because usually if it is a function, then we need to call this function by using this, right? But we don't call it by using the name here, underscore underscore init underscore underscore. It can be invoked in another way. Two things that we are going to learn today. There's init, and some of the things is str. I'll show you just str. Let's see, this is str. Not in this case, but anyway, we'll say that. Okay, so quit. Close this. This is a special function that construct the class. The components that we use to construct the class length are focus length and aperture. Focus length and aperture. And parameter here, self, is started with the self. Anything that you define within class, any function, if it is defined for a class, therefore that function is encapsulated, then parameter, the first parameter should be self. And after that, the parameter that you use, focus and aperture, that is here, this right-hand side, this is this focus, and aperture is that aperture. Left-hand side, therefore, this focus is not just a focus. Look at this, it's self.focus. Self means me, mine, right? That's mine. So my focus. My self.focus, my focus. It is not the focus passed from color. Usually, if it is a function, then the focus and aperture needs to be passed from the color side, right? So the values passed from the color side is on the right-hand side here. So this focus is the same as that focus. This aperture is the same as that aperture. Left-hand side, self.focus, that is not this focus. That is not that focus. This is my focus. This is my aperture. What that means is this is my static aspects about lens. This is my static aspects. In other words, this is my variables. My variable. My focus. What is my focus length? What is my aperture? My focus length is given by the color. My aperture given by the color. If those two values are given, passed from the color, then this two variables, two attributes, two fields are ready to use. So using those two fields, specific object can be constructed. In other words, a specific object can be initialized. Remember that given class definition, this is because this is one skeleton, one blueprint, you may say, whichever convenient to you. This is a blueprint. This is a skeleton. If it is a skeleton, then you can put that some of the skins and muscles, therefore it could be an object, right? Skeleton is not an object yet. So this is a muscles and skins. They can be assigned to constitute an object, one specific object. With another focus and another aperture, we can construct another object. by having different focus and different aperture, then we have different, not really value different, but different times, different sets, right? It could be different objects continually. So that is here. How can we construct? We can simply, first the lens one, this is a variable, okay? We call this object identifications, these objects. This is variable. This variable is assigned by this right-hand side. So evaluation of this right-hand side is lens. Lens is a class name here. Lens, open, close parenthesis. There we have two values. First value is the value for init functions focus. Second value is the aperture for that is in the second parameter in the init functions. So if we say lens with the two values, then this function, init function, is invoked. This guy didn't say anything about the init, right? Therefore, it's called the magic functions. This is a constructor. When we construct an object of lens, then we need to use lens. This is because this is blueprint, right? So using this blueprint, looking at the init function, if it requires two parameters, then we use two parameters into this blueprint. Therefore, object can be created, and we call that, the first one is called the lens 1, second one is called the lens 2, and lens 3. Okay? The value can be same, because there are multiple different lens. Lens 4, we can repeat this. There's a lens, same value. Not necessarily there should be all unique. In our case, if we describe it about the students, then there may be many students having the same values, right? Same first name, same last name, same major, same GPA, whichever that we describes. If we want to make each objects uniquely different, then we need to include more attribute here, right? More parameters for init functions. Not only these two, but maybe 100 different dimensionalities about the object features. Then we will have all unique. But it is not necessary. There's no such. It's not really issue. It may be the issue in database, but not in codings at all. So this is the way that we define class. This is the way that we create multiple objects based on class definitions. In order to create an object, then we need to look at underscore underscore init underscore underscore functions. Okay. If you look at this, then this is a constructor. This function is a constructor. Underscore underscore init underscore underscore. We have two other functions, right? By, display, actually, it's not display, it's stl. Oh, well, yeah, it's different, right? Okay, this is underscore underscore init underscore underscore. By, different behavioral aspects of this lens class. So by, it has two parameters when we call this by function. One parameter, self is not used when we invoke this, right? Self is a modifier for the variables. Owner, but if we say self.owner, then that is my owner. And this owner is the owner given from this function invocation. When this function is invoked, the value for owner needs to be included. Therefore, that owner can be the owner here on the right-hand side. So that will be assigned to eventually my owner variables. Could be display. If you want to display in different ways, then self, then there's a no nothing, which means display can simply display, right? Because there's no value that we need to call this display. Self is my own, right? If we call this display, then it returns, it prints some placeholder here. Curly brace owns a lens of focus length, this and aperture, the other, dot format. See here, this is from here there, that is a string. this string has this format functions. So this format can be invoked by multiple arbitrary number of variables, depending upon your placeholder in the string. So we have 3 placeholders. So we send 3 values. This is actually value. Self.owner, if it is already given by this owner, then there's owner. Self.focus, self.aperture, that can be all available. If it is not available, then it'll be an empty, that is a nil value. But other than that, based upon this initialization, then definitely we will have a focus and aperture. So self.focus or self.aperture can be available. The value is available. Self.owner, if we invoke this by, then we know self.owner. But anyway, so for this constructor, we can create objects. So we create 3 objects, right? And then based upon those 3 objects, this is still remains the same. And then lens1.by. Lens1 is the objects of this kind of lens, right? This is real objects with this focus length and the aperture. We call that lens1. So lens1.by. This is an object. That object is constructed based upon this class. So this guy, lens1, has also the property of the function by. Okay, so we have a by. This function by takes one parameter owner for, so photographer, so for John. So John is sent to this buyer. Then self.owner is now John. Okay, so up to this, that is okay, right? And then this guy says print lens1. Print object itself, lens1. Lens1. Objects, as I said, if it is constructed based upon skeleton, based upon blueprint, based upon class, then there's encapsulation, right? It's not only one value. When I say here print lens1, then which one can be printed? If we don't do anything, then it prints object identifier. ID will be printed. Looking at the ID, we don't know what it is. Here in Python, ID looks some recognizable, but some other languages, like Java, if we print object ID itself, then that is ugly ID, which means not recognizable. I don't know what it is. That is ID. We don't need to know ID, right? ID is a sum of strings that identify an object, right? So you can print unless this function is defined, which is underscore stl underscore. This is another magic functions. We know init function, that is a magic function. We call that constructor. Underscore stl underscore. That is another magic functions. It returns some literals, some string. Then when we say print lens1 and then skeleton of this lens1 or class of this lens1 objects has this function defined, then according to what it returns, that it will be displayed. So we can say something here, return something. If we want to return owners, then you can say return self dot, because we have self here. So self dot owner, then owner of that lens will be returned. If I say print lens1, then hey, that is a John's lens. Depending upon your definitions. If you say here return focus and aperture, return self.focus plus self.aperture, then when I say print lens1, then it returns focus length is this and aperture is that. That is returned. So instead of displaying identifier itself, we want to display something as we want by stating here return followed by whatever that we want to describe. If we want to return anything that in these print statements, instead, as a return statements, then this will be returned. So this is manipulated by designer, the programmer. So two magic functions defined for length class, and more functions available. And static functions, we have focus, aperture, owner. These are nicely defined, although we don't say focus, aperture, owner. You can say that here. Focus equals simply maybe 0, or focus equals some string. You can initialize that by saying before these definitions. Or you can create that static functions as you define. You can define static variable like this separately, independently here, or it can be created. It can be defined automatically if you simply use it in your as you develop your functions. Okay, like this. By then owner is created. Init, then focus and aperture created. You can create it. You can define it explicitly here, independently from the functions, or you can simply use it as you use, like this, self.focus. Automatically, focus is the variable for length. So what is class? Class is a group of objects. If you are representing in the same templates, we call that objects in a class. So we can JP Morgan's, Goldman Sachs, Blackstone, they are all in the class investment bankings, right? IB. Peter, Adam, Kelly, Chris are in the class students. Then they are objects of the class, object of the student's class. A class is defined over the common aspects of all of its objects. Like looking at these students, then we can define a class, and all the features used in this class definitions are common for all of those guys. How can a class be represented? A class is defined over, we already said that, right? Class can be defined in two aspects, static aspects and behavioral aspects, as I said here, right? Consider grading schemes in a class. Grading scheme is the same as shown in the syllabus, so that this is a function that we looked at. We defined this multiple times already, right? Definitions, grading. This grading definitions receives grade, and then we, using this conditional statements, then we can give the grades. So the class definition has variables and methods. Method is nothing but functions. So class, let's say section, then we can remember that this self.student, self.instructor, self.title. If we see the section of a class, then we know who's the instructor, who's the students, what is the title of that sections. That can be this students, instructor, title. We can define this static aspects as a variable independently from these functions that I explained, right? Or without having this, as we use this function, as we define this function, then students can be automatically the static aspects of sections. Instructor automatically static aspects of sections. Title is automatically static aspects of these sections. So as I said, two ways. You can initialize it, or you can simply use it as you use. It is known that way. This is Python. Python is in this way, it's not really formal language, but it's easy to use. This is a constructor, init functions or methods. In object orientation, function can be called a method. So it could be a method or a function, whichever convenient to you. But in formal way, the functions defined in a functions in a class, functions defined in a class is called method. So grading. Remember that grading is a function that we looked at previously. It takes a grade and return letter grade. If it is defined within a class, then parameters should start with the self. And number, this is some points, right? So based upon these points, we can generate a letter grade. So having this class definition, so class needs to be defined first. Number one, we need to define class first. Number two, create objects. Okay, so how can you create objects? So section by sending students IDs. Students ID is like this dictionaries, and then instructor John, and then title Python. Then one section can be created. We call that class stud. Once it's created, then if we want to print, how can we use? So the class is defined, object is defined. As we define objects, could be we can make this student dict is not atomic value, but this is another variables. So that variable should be defined before we use that, right? So this student dictionary is defined in this way. So class is ready, objects are created, then we can invoke it. As we invoke, we use print statements. In these print statements, placeholder is taught by placeholder. So first placeholder may be a course title. So in that function call format, title, whose title is it? This specific object title. Okay, this is a class student, that is an object. See here? This is a variable. That variable, the value to this variable assigned by this function, we call this a constructor. This object constructor. The outcome of this object constructor is nothing but an object. So that object is assigned to this variable. Therefore, class stud here is an object of a class. Title of that object, then that specific object dot title. Therefore, we know what value it is. The specific object, which is this specific object's title. If it is a specific object, that is if that object is constructed based upon this class, then looking at this class, therefore we have title, right? This init is already defined earlier, right? So title there. Title and instructor here also. So class to that instructor, there's nothing but John. These static aspects or any of these functions can be invoked, can be accessed by using dot operator. See here, dot. This dot operator specifies the objects and aspects of that objects, so that this objects, aspects, either static or behavior aspect, can be specifically a certain value, because we specify a specific object here. We indicate that object. I want the title of that object. That's what it is. So we have object dot value or object of dot function name. Okay, this is the end of my lecture, and I am going to, let's make the lab. I already posted, so you may be able to find out. Right? I believe it is available somewhere on your so everybody has that the Google Note. I want anybody to raise your hand indicating that you are ready to go. Good, Anthony. All right. And Jessica Bora. Yeah, thank you all. This is the lab. Look at this first code here. Consider class objects, IASP 505, IASP 455, etc. Okay, so we can say student Adam, Sam, Peter, Chris, and this is a dictionary of students. And because it is a dictionary, we have key and value pairs. And title, Python, instructor, John. So we can print the student's title and instructor. And we can also say in this print statements, then we see by running this, then we can see John teaches the class Python to the students, these guys, right? This is simply a flat coding. In object orientation, I explained that already, right? This. And in object orientation, what we need to do is we need to do this. Defining class, constructing our objects or multiple, one or more objects, and then accessing static element and invoking dynamic elements. Okay? Define class first and construct multiple objects. From there, either we can access the static aspects or invoke dynamic element. So we'll follow that. So defining class. We can define a students using init. Okay. And I didn't, you can say here, as I said here, name equals initialize, nothing. And then major, that is also string, right? So we do anything. And then course, I don't know, course, maybe string. Okay, you can do this. Or without having to this, you can simply use it. So as you use, it is, this Python knows this already. Okay. This is a magic functions. Another magic function is stl. This is something that we want to see, right? And then we want to add more class, but right now we don't do this yet. So let's put this comment in order to run this. Okay. So if we do this, then it runs, right? Although even do this, if we say simply pass, it is okay. There's no errors. So this is definitions. This grading, we did that already, right? Construction objects. Then as we construct it, then we need to construct it based on this. See, name, major, course. So course could be, oh, but by the way, in this case, a list of courses, right? Then we can, it's okay, this initialization. But if you want to, you can do another way like this. It is up to you. Doesn't hurt. So we can do this. If you want to invoke, then, for example, print student1, see what happens. Oh, this is, I need to make a code. Okay, just print student1 and invoke it. Then student, oh, by the way, student1 because we defined stl, right? stl is defined like this. Remember that this stl, without having to call this stl, if we want to print an objects of student class like this, then it can return this. But if we didn't have this underscore stl underscore function defined, I will comment that. Then rerun this, and then rerun this. And when I run this, see what happens. It doesn't print like this, but it returns ugly ID of student 1. It's not really ugly, as I said in Python. Like this. Something it knows, oh, that is a student object. Right? It knows something. And then that object real ID is like this, hexacode. But at least this guy knows, oh, this is a student object. Okay. If we say print student 2, then this is another ID, right? This is ID. A little bit chilly, so I need to turn on my heater. Okay. Hopefully you don't hear any noise. But if we have this is definitions, okay, then we can rerun this. And rerun that. And if we run this, then we have different ways of displaying ID. If you want to manipulate the way that you display ID, then you need to manipulate that here. Right. There's a way that you invoke. If we want to invoke, for example, print student 3 dot name. What is the name of student 3? Then quiz. By the way, if you look at this constructor, then we made the quiz objects, right? And if we want to say what is his student 3 dot major, then quiz major is a cyber. That's what we have here, right? That's not the same as CS quiz. This is a cyber quiz, because we know it's not any major, but this is a specific major of this object, student 3. And having that all together here, class sections, and we have this grading. Okay, so accessing, as we say, student 1's name, major of student 1, course of student 1, using dot notation. Okay, the point here is to use dot notation. Then we can get that. Okay, insert a value to a dictionary students. Before we do this, back here, let's see, where is it? Here, defining. Yeah. Class. Here's what I want. I want a copy of that and practice here. Okay, code. And you can say, this is my practice. Okay, Oh, we have also, I want to bring one of these. Okay, student 3 for my practice. So this is a definition of a class, and this is object construction, and this is use. So student 3 dot courses. I run all together. Oh, STUD. So the course taken by student 3 is IASP 520. That is this, right? So this, Chris wants to add more class. That's what we want to practice here, add. So for example, I want to do, student 3 wants to add class. I want to send the CRS, whatever we want to assign that. But I want to create, this is initially the course that, this is the course initially created for on object creations, constructions. But later we want to add more. Then we need to add it, because if we already have course. Course is nothing but a list. Okay, without having this, it's still fine, because that is already a list, so that I can do append CLS. So I want to put here, say, $555, and I want to rerun this. Then initially I have IS 520, okay? But using this new implementation of that function, I want to append this new the value through this function invocation. And function can be invoked by object dot function name and the value to pass. But this function requires one parameter, right? So I put that parameter. And in this case, you need to say in string. If you want to make another way, for example, add a set. This CRS is list. So one more time, if I want to here a set within this, and I want class A and class B, then I have extend. Oh yeah, because so therefore I need to see here, rather than add, I need to put here add set. If I call add itself, then it goes here, add. And this should be a string only, but if I add a list, then list is appended to a list, therefore it appears like this. Okay, but if I do, instead of calling this function, if I call the other function add set, here in this case, then it'll be properly like this. So this guy has those 4 courses, right? So probably I think you now understand how object orientation can work. So in object orientation, define a class first and construct an object, and you can access any of this and manipulate it using this object dot function name or object dot variable names. Okay. Any question on this simple example. Okay. So we invoke that. I want to practice this. Okay, homework 1. So, I want to extend this so that you can define class, 3 classes. I'm sorry, not class. 3 classes: department, students, and course. Department, student, and course. So this class is not going to be reused, but based upon this class definitions, get some understanding, then I wanted to create department, student, and course. So each class skeletons or blueprint is provided, so it is already provided here. So we have class department. You don't need to, I think department is fully given to you, right? We have init, so that these 2 department name and director's name are used to initialize for object creation. And then there is a stl, another magic functions. This is class department, and then class students. Then we have init and stl, and then add register, and average function. Grading is given, right? It's already given, that we looked at many times. And then final grade. Yeah, those functions. Oh, this is given also, right? If it is given, do not change it. I know some students wants to do another way. Don't do it. If I find it, you don't get the credits. Use this as is. But only I want you to do, if I say here, your code here, then you need to put that code here. Here, your code. This is the students class. Okay. And then we have another class, course. So we practice a little bit of those, and then course. Course has 2. Course, there's a given also. Yeah. So among those 3 classes, you need to do code only for students. Only those 3 functions. And then it'll be complete. And then don't touch this. All others remains the same. And then random number generated to assign students points for each course. That can be done here. For example, for each students has a course, right? Course has a score. So student Bob department. Yeah, this kind of students 1, 2, 3, 4, 5 can be here. These guys. Initially, the student name and department, where that students is in what major. And after that, students can register the courses. Courses are available here. ISP 500, 505, 555, something. The object of courses are constructed. And we invoke student 1 now, register. Students class has a register. It takes a list, so register it. And 1 more student is assigned. Student 4. Oh, no. This is the initial registered. And then there is another one, add. Remember that add, regist takes list parameter. Add takes arbitrary numbers. So if you go back to the students class, then register takes CRS. This is a list formats. Add, see here we have star. CRS, what that means is it is this add function can take arbitrarily number of parameters. All those parameters are coarse. So when we call that, in this case we sent to IS5555, which is this is not this kind of string. This is not the string, but this itself is an object. IASP555, that is an object. Already constructed based upon course class. Same thing here. CISC555, that is an object already defined. So student has the CRS. For CRS, for each student, then students has a list of classes. This is a list of class, so that another 4 statement possible, right? For each element in that list, we can assign the score to that course list. So each student has a different number of classes, number of points for the courses. Like here, Bob has intro, this is course title, 87 points, found 81 points, so that average is 84.1. So Bob earns B. Chris, this is course title mobile, 57, average is 57.0, so Chris earns F. Based upon some criteria, if it is a F, then report this Chris to, because Chris is in CS department, CS director. Who is the name of the CS director? Chris. So for example, CS department director is Chris. Cyber department director is Brian. And this Chris, I'm not sure the Chris, maybe this Chris. Yeah, this Chris earns an F. Therefore, if this Chris earns an F, then reports to his department chair, Chris. If this Chris has some probation, then his status needs to be reported to the department chair of Department 1, DPT1, which is Brian in this case. Right, that needs to be, say here, reports. So this Chris is reported to Department Director Chris. This Chris is reported to Cyber Department Director Brian. Peter is CS Director Chris, depending upon their credits. So I believe that is what I explained. This. Each of the class skeleton is provided and requires your code to complete. Some code needs to be completed, right? A few functions need to be complete for classes properly. As you can see, the sample runs. I explained the sample runs already, right? A few objects are created for classes, and the static and behavioral aspects are accessed in a few different ways. Some functions are also given that can help the program to run well. And I didn't say that here, the report, but I think some comments somewhere that I list of students, their students show final grade. If average is lower than 70, then report the student's name to the major director. Yeah. Okay, that is your homework assignments. As I said, do not submit this as your work, but I want you to submit in the separate plain text Python files. So you can simply copy all of. Once you complete this, well, then you can copy everything and put it in another separate files, plain text. But plain text Python files, what that means is that it should have a proper indentations, and it should be written in proper Python statements. Any questions? This is it for coding. This is the end of the coding lecture. Hopefully that you learn some concept of coding skills, or somebody may I know some students is really great in coding at this point. Any question?